Okay, this is Friday, December 6th, 2019. Thank you for your patience in cyberspace. Johnny, Sawyer, and Julia, as I was unable to appear before you the last couple of days. We're going to go over page 244 and 245, that homework you had on Wednesday, right?
Homework.
Make sure you know what you're doing when it comes to realizing that rational numbers can be written as a fraction or they can be written as a decimal. They're the exact same thing. It's just two different ways of saying it. I can call him Zacchaeus. I can call him Mr. Schwarzentruber. I prefer to just call him Zacchaeus because that's easier for me. I like decimals. But I could call him Mr. Schwarzentruber if I like fractions, right? And then we're going to learn that if I wanted to, I could just say, hey, that kid. And that would be like percents. Because when it comes to rational numbers, fractions, decimals, and percents are all the same value. They're just a different way of saying it. So really the crux of Wednesday, you know what that word means, crux? Is that a big vocab word for you? Crux, the gist, the main thing Wednesday was how do you make a fraction a decimal? The fraction bar is a division sign. The fraction bar is a division sign. So 1 over 2 is, let's start real simple. Why does 1 over 2 equal 0.5? Because if I do the division, and by the way, if you're still stuck in this rut, you don't know which one goes inside the box, I take you back to when I was young, I still do this rhythm. I just did it in my head. If this is 1 divided by 2, I wrote 1, and I did this rhythm. Ready? Divided by, and 2 goes on the outside. So 1 is same as 1.0. Boom. That's how a 1/2 is 0.5. That's clear, right? If it's not, raise your hand. Okay, so if you go back to 244, what do we have to do? 1 through 20 something. Why would I put 24 when there's 25 there? All right. Yeah. Must have been a typo. All right. Go all the way back to number 1. Make sure we're doing this right. It says tell whether the number is included in each of the following number groups. Okay. Going back to number groups. When you were young, you just learned counting numbers. Remember those days? You probably don't. But maybe when you were 2 even, you started learning to count. In preschool, you know how to count to 10 before you went to kindergarten. Those are called counting numbers. Then they added the number 0. 0, believe it or not, you didn't learn that at first. You learned 1, 2, right? You're counting things. That's how you learned numbers in the first place. And that's why, by the way, what number system doesn't even have a 0 that you know? Roman numerals. Arabic does. Michael, were you trying to be funny there? We use the Arabic number system.
He doesn't even know what it is.
Okay, so at least he said the word right. Roman numerals didn't even have 0. Why would you have a 0? You use numbers to count things, right? So the Romans didn't have a 0. What would be the need for it? All right, so when you add 0, now you're talking about whole numbers. Then when you add all of the numbers in between the whole numbers, Brett knows that between 0 and 1, there's an infinite number of numbers. What? Like, literally, you can break it down to 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1/28, 1/256. You can break it, like, you can just keep chopping it up. And theoretically, it's infinite. Like, you can keep going smaller. And theoretically, right? Because we know there's such thing as an atom, right? Can we see an atom? No. So how small is that? What fraction would you put on how small an atom is? What fraction of a millimeter would that be? We can't even conceive of it, right? So fractions come into play when we talk about, what's the R word? We got rational numbers. And fractions can be written as decimals. So number 1, what number group does it go into? Does it go into rational numbers, integers, or whole numbers? And it could be more than 1, by the way. Rachel, what'd you get? Zero's an integer? Yes. What else is it though?
I don't know.
Anybody else? Yeah?
Rational and whole.
It's rational and whole. It's all of those. How about the number 0.55? First, let's tackle this one. Is it a whole number? No. It's part of a number, right? Right? Okay, it's in between 0 and 1. Is it an integer?
No.
No, integers are your counting numbers and they're opposites. 1, 2, 3, -1, -2, -3. So what's that leave us? It's a rational number. You know why it's rational? Not just because it's a decimal, because it can be written as a, who said that? Who said that? It can be written, Noah, because it can be written as a fraction. Hold on. Can't all decimals be written as fractions? No.
No.
Some numbers are not rational, but irrational. 0.55 is rational because it ends. Make sense? It either ends or it repeats. So 0.55, you would write 55 over 100. You would reduce that to 11/20. That's it. Comes out perfectly. There are some, like you've all heard of pi, right? So sometime in 6th or 7th grade, or at least 6th grade, last year I had Mrs. Reed, there's Pi Day, and pi is irrational. Is there an end to it? So we try to make it rational, and we give a, did you learn the fraction for pi? Did you learn the fraction? 22 over 7. So we kind of try to simplify it, and if you use it as a fraction, it comes closest to 22 over 7. All right, how about -14? First of all, is it a whole number? Is it an integer?
Yes.
Is it rational?
No.
Why wouldn't it be rational? First of all, let's tackle the first one. It's not whole. It's not whole because it's negative. It's an integer though. Fix that. -14 is not a whole number because it's negative. It is an integer because it's the opposite of 14. And it's rational. And how about 0.3? What category would you give 0.3? Start again. Is it whole? No. Is it an integer?
No.
It's rational. 3/10. No. It's rational if it ends or repeats. Irrational is doesn't end, doesn't repeat. Like pi. Goes on and on and on. That means the 3 is going to repeat because it's this. What's the fraction for 0.3 repeating? Go ahead, say it. Thank you, Ethan. 1/3, because if you do the division, Noah, 1 divided by 3, guess what's going to happen? Do you see a pattern developing, Noah?
Yeah.
It's just going to keep happening. It's 1/3. Number 5. Let's go quicker now. Number 5. What is that as a decimal? 4/5. Jonathan. What you got there for number 5? We're on a fog today. I'm the one who should be on a fog. Yes. What is it? 0.8. Very good. Number 6. Anybody, raise your hand. Let's go. Quick. Bella. 2.25. Number 7. Right behind me, 0.3 repeating. Number 8. By the way, if you don't have your decimal fractions memorized, you already knew 1/2 was 0.5. By now, you should have 0.25 for 1/4, 0.75 for 3/4. If you don't have your fourths memorized, you got to get on it. And actually, right now, you should have your eighths memorized. Eighths, you count by 125, 125, 250, 375, 500, 625, 750, 875, up to 1. If you don't have them memorized, memorize them. So number 8 is 1.625. If you didn't have it memorized, you'd have to do 5 divided by 8 to get the 0.625. Y'all listening? Memorize those. Listen, why did you learn your times tables through 12 when you were in 3rd grade? Why'd you do that?
Because we had to.
No, not because you had to. There's a reason for it. Why'd you do that? Why was it important that you memorize those multiplication facts, David?
So you don't have to use your fingers?
You don't have to do it all the time. You were supposed to memorize them. Anybody ever play the snap game? I say 7 times 8, 56. You should have already said it. 9 times 8, 9 times 8. There you go. 6 times 8.
48.
Okay. So if they come to you that quickly, now when you do problems that involve 3-digit, 4-digit multiplication or division, you don't have to sit there and take 3 minutes to do one problem because you can't immediately tell what the math facts are. Same with these fraction to decimal equivalents. Memorize them so you don't have to keep doing it. Every time you get an eighth, you shouldn't have to do the division. 1/8, 0.125. 2 eighths, which is the same as, let's reduce 2 eighths.
1/4.
What's 1/4? You got a quarter. How much money you got? 0.25. Okay, so then 3 eighths would be another 125 on top of 0.25. And you're thinking, what do you mean? Because 0.25 is the same as 250. So Seth can put 125 on top of that. And now he knows that 3 eighths is 0.375. Plus Seth plays baseball. So it's convenient for him to say, I play a doubleheader. I go 3 for 8. What's my batting average? 375. 4 eighths is the same as 4 eighths is the same as 1/2, 0.5. So 5 eighths, what do you add to the 0.500? 125, 0.625. Memorize them. Number 9. What's 6/10 reduced as a fraction? Elise. You didn't reduce it? David. You're asking me or telling me? 3/5. 0.6 as a fraction, says Casey, is 6/10. That reduces to 3/5. Number 10. It's going to be negative. 1 2/100. What does 2/100 reduce to? 1/50. So the answer to number 10 is -1 1/50. Number 11 is interesting. When it comes to fraction to decimal equivalents, you'll find some interesting pattern develop with your ninths. We've already done the 3/9, which is the same as 1/3, right? What happens? The 3 repeats itself. What do you think? It's the same pattern for all ninths. The decimal for 1/9 is 0.1 repeating. The decimal for 2/9 is 0.2. The decimal for 8/9 is 0.8. And put the line over the top to show Noah that 8's just going to keep repeating itself. Does that make sense? Have you memorized your 9s yet? Your ninths? Rachel, did you memorize your ninths yet?
No.
You just did. Let's start again. Ready, Rachel? You're going to say yes in like 5 seconds. All ninths, Rachel, the numerator repeats itself. So let me ask you again. Have you got your ninths memorized? You didn't say it with much conviction. What's 1/9 as a decimal? Point. Repeating. What's 7/9 as a decimal? There you go. You got it memorized. Number 12. 12's a tough one. 12's tricky. What'd you get for 12? Raise your hand. Let me know. Come on. You at least did it, didn't you? Even if you didn't understand what you were doing. No, what'd you get for 12?
I got 5,300.
Okay. That seems like it would be the answer. Watch. If the problem said this, if that was the problem, Sydney, it would clearly be 53 hundredths, right? You with me?
Yeah.
Okay. 53 hundredths. Raise your hand if you don't understand that. 0.53, ending in the, not the tenths, but the hundredths place, is 53 hundredths. I need you to raise your hand if you don't get it. Okay. Is that what the problem says in number 12?
No.
No. What's it say? 0.53 repeating. So it's a little tricky because if it was strictly 0.53 over 100, it would be 53 hundredths. It's 53 99ths. Just listen, it's just a little tweak to show the difference between straight 0.53 and 0.53 repeating, because they're not exactly the same number, right? They're not. Listen, this doesn't matter to you normally in life. Jonathan, you okay?
Yeah.
Why is everybody so tired? How many tests do you have?
Because of Mary.
Wait, heritage projects due when?
Today.
I was wondering. I'm looking around like y'all are looking like it's like 11 o'clock at night. Okay.
I'd be completely awake at 11.
All right, focus. Back here. All eyes back here. Normally, in everyday life, there's not much difference to you. Never will there be between 0.53 and 0.53 repeating. However, if you go into engineering or medicine or any other field like that, there's going to be a big difference between 0.535353 and just 0.53. Because when you start dealing with really small measurements, there could be a difference. There are some medicines that are really powerful. You know that? So the difference, 1/100th of a difference in a milligram means a lot. See what I mean? Or surgical instruments, right? They don't go to do surgery and use a blade like that's on scissors, right? That would be bad. Let's go do brain surgery, and the thickness of our blade is like a scissor blade. Would that be crazy? Okay, so the instruments they would use to do surgery on a person, well, if it's a big organ, like it's not real intricate, they wouldn't use anything this thick, but their instruments would be very, very thin. But imagine you're dealing with the smallest of blood vessels near the heart or the brain. Then, I mean, it's almost as if like there's no way it's even that thick, but the numbers would get really small, and the difference between those tools means a lot, right? When you're dealing with things really, really small. So 0.53 and 0.53 repeating aren't necessarily the same. Don't worry about that too much. I'm not going to ask you a question like that on the test because that's just kind of, it's not cruel, but you do need to know the difference. That if it's straight 0.53 compared to its repeating, 99. All right, moving on. Number 13, you should have gotten 1.8 inches, 1.78 inches, I'm sorry, 1 7/8 inches, 2.1 inches, and 2 1/9 inches. What's the difference between 2.1 and 2 1/9? It's this. What do you need, Isaac? If it's absolutely necessary, Isaac, and not just because like I'm ready to fall asleep and I got to get up and walk around. Is that the truth? If you got to go, you got to go. Noah. Listen, what's the difference between 2.1 and 2 1/9? What's 2.1? What's the next digit after the 1? 0. 2 1/9 is 2.1. 1 repeats because it's a ninth, so it's 2.11. Do you see the difference? Yep. What's larger, 2.11 or 2.10? It's a slight difference, but it's different. That's why they're in that order. Any other questions? And the difference between 1.8 and 1 7/8? Remember when you do your eighths? That's 7/8. What's larger, 1.800 or 1.875? Lauren, you with me? Okay, numbers 14 through 24, I'm gonna go fast, because we gotta move. Running out of time. Ready? If you missed it, mark it. 0.75. Hopefully nobody missed it. 3/4 is 0.75. Number 15, negative 0.1 repeating. Number 16, negative 0.48. You could have done that two ways, ladies and gentlemen. I said I was going to go faster, and now I'm stopping. You could have gotten 0.48 by doing 12 divided by 25. You could have done the 12 divided by 25 thing. Or, if you're like Zacchaeus, you could have said to yourself, you could have said that to yourself. Anybody do that? Did anybody recognize that 12 25ths, rather than doing this, 12 divided by 25, let me help you out here, Micah. Anytime you can set something equal to 100, do it. Because look, 12 25ths, you don't reduce it. You can make it a larger fraction. And if you can get your denominator to be 100, boom, there you go. 0.48. 48 hundredths. You get that, Dina? All right, number 17. Toughest one so far. 0.58. 3, only the 3 repeats. Sometimes you'll get a series of 2 or 3 numbers that repeat. In this one, it's 0.58. Only the 3 repeats. Number 18, negative 0.16. Look, use this strategy. It's 25ths. Multiply top and bottom by 4, you get hundredths. Negative 0.16. Number 19, 0.54. Same strategy. It's over 50. Multiply both by 2. 54. Are you following this? Is this helpful? I hope that's helpful to avoid having to do the division. If you can make it equal to 100, something easy like 25 times 4, 50 times 2, do that. 0.54. Number 20, 3.65. And it ends. 3.6875. Number 21, negative 0.4125. Number 22, 0.5, the 3 repeats, just the 3 repeats. Number 23, negative 14.63636363, the 63 repeats. Both, you got to put your bar over both digits. Everybody got that? Number 24, negative 0.424242, so the bar is over the 4 and the 2. Turn the page. Yesterday was just adding and subtracting decimals, right? And you only had to do the it's turn now sections. All right? I got to get you started because we do got to. All right, so you did all that work this week. You got one more thing to do here in algebra, and that is 11 through, we'll just make it 11 through 19, okay? Since you had all that to do. 11 through 19 on 249. Show me you know. When you add, subtract decimals, Rachel, what's the most important thing?
What?
When you're adding, subtracting decimals, is to line up the, and then you could fill in places at the end of each decimal with zeros. Anybody need that clarified again?
No.
Evelyn, when you're adding and subtracting decimals, the most important thing is you line up the decimal points. And then Evelyn, if one of your numbers has more digits after the decimal, what could you put at the end of any decimal and not change the value? The 0. I'll do one on the board as you're working. 11 through 19, page 249. Yep.
I don't have any pencil.
Well, I find these work way better. So I've had one, but it doesn't really work as well as this. All right, number 13. Listen. Triangle over there. Pay attention. Ready? Number 13. First thing I notice about number 13 is one's negative, one's positive. If I'm adding a negative and a positive, what's the rule from way back in early September? If the signs are different, find the... So, before I start though, what's my final answer going to be? Negative or positive? What? Negative, because I'm looking at a -6 and a +2. Remember, it's find the difference, use the sign of the larger one. So, first thing I got to do is find the difference. 6.08 minus 2.661. Evelyn, most important thing, line up the decimal points. Now I go to subtract, there's nothing up here. How do I fix that? I can add a 0 to the end of any decimal number without changing the value. So now I've cleared that up, and it's a matter of remembering how to borrow when you subtract. And the final answer, Noah, when you look at the original problem, it's -6 and +2 that you're combining, right? So the final answer is going to be negative. Who got -3.419? Very well. Okay, listen. I had, the signs were different, so I got to find the difference between these two numbers. 6.08, this number down here had 3 digits after the decimal. This only had 2. Well, that's okay, Dina. I fixed that by putting a 0 there. Because I could put a 0 on the end of any decimal number without changing the value. Okay. I can't do 1 minus 0. It's 0 minus 1. So I got to borrow from the this place, hundredths place, and I put a 1 in front of this number. It makes it 10 minus 1. You don't remember those days of borrowing?
No, I didn't.
Okay. It's an addition problem, Dina, but you're adding opposite signs. So you find the difference. Signs are different, find the difference. You didn't have one of those moments where, remember, what's his name? Brian Regan? Science fair? Oh, that's due today. Tell me you did not wake up at like 6 o'clock and go, that's due today. I had like 3 months to do my heritage project.
I thought it was 6 or not.
No, I was done like one. I went at 8. I was done. No, but I was wondering if I have to drink it along to get it, like bringing it, then it'd be like -50%.
All right, page 249, 11 through 19. Have a great weekend, Julia, Sawyer, and Johnny.
Johnny doesn't do his homework.
He honestly probably doesn't.
He tells me.